Hello. Hi, everybody. My name is Simone. I work as a developer relations manager for Edge and Node, and I work on the Graph protocol. And today a little bit talk about the rough ideas of how we can bring Web2 data into Web3, obviously with the Graph. And let's jump into it. So Web2 data, what is this? I mean, it's like a big term, and but I have some use cases in my mind that I'd like to discuss here. So I spent some time on ChatGPT to find some, not ChatGPT, that was Midjourney, getting a little bit addicted to it for my presentations, but to have some use case that we can describe here. So one classical Web2 data use case is airplane seats, free airplane seats. Like there's a whole thing about airplanes and seats and which are free and which aren't, and so on and so forth. And it's a big industry also going on with kind of that data brokerage. But that's actually interesting Web2 data that we might want to bring into Web3. But the question is how? Same and very similar kind of data sets are free hotel rooms, especially maybe the ones that are short-term free. It's again, like we have data sets of hotel rooms that are free that hotels would like to kind of give away so that people can book it. But again, like very complicated data systems currently. And also like one use case that's interesting that we see on the bottom right is actually server data or like traffic data. That's a use case that is actually already explored. I go into this deeper, but like there's this idea that all these servers, they all collect data all the time, like access data, when someone accessed, how quick was the response of that access, which website was accessed, and so on and so forth. Like also very interesting data that can be used or also published. And last but not least, the idea of and that's a weather station. I don't know if that's clear. Kind of the idea of having weather stations that publish data like publicly somewhere, and that then we can then kind of get that data from the weather stations back somehow into Web3. So that's stuff that we explore. All these kind of use cases have in common, like there is a lot of data. It comes from a trusted, centralized source, but like the usage of the data could be very interesting. So we don't necessarily need like a trustless, the pure system of like, oh, we really have, which the blockchain by itself represents, is kind of good enough. Like, so if an airline says, these are the seats that are free in my plane, like we don't need another oracle that kind of says that data is true because the airline says we can trust it to a certain degree. But anyways, and also like the data is useful, and it's something that we might not want to protect because like the airline is very interested to get rid of the empty seats. They don't necessarily need to have like an access control of who can see which seats are empty or not. At least a subset of seats are there. Same with server data. Some amount of that one we might want to give. Sure, like we don't want to publish all the IP addresses and stuff that query our server, but like some stuff we might want to open. And the problem is often with that data is that the data is there. It might be useful for other people, but it's not directly useful for the business that collects that data directly, so they don't publish it. And so in the next couple of slides, I start to kind of develop this idea of how can the graph help to publish that kind of data or make it more easily accessible. Nice, let's jump into it. So what is the graph? I don't know, who knows what the graph is? Please raise your hands. Okay, so we can make, anyways, a quick refresher. So that could be an animated GIF that takes this mess of all these different balls, which represents transaction on Ethereum, into buckets of ordered data. So kind of the graph is this infrastructure protocol that sits in between, initially built for front ends that need to display data from the blockchain. And the graph, if the subgraphs, they sit in between. So like they make it easier for front ends, but also like data science applications to access data from chain, because like we know, the Ethereum blockchain archive node is 3 terabyte compressed. So that's not easy data to quickly go through. So the graph sits in between as kind of this indexing and query layer of blockchain data. So we talk about like the data layer of Web3. But also the graph is a decentralized network. I think that's the most important thing. Like there are 281 indexers. These numbers are actually changing all the time. The index is coming and sometimes they go, but like it's roughly 200, but mostly growing, right? 281 indexes. We have like 11,000 or more delegators, more than 2,500 curators, and more than 1,100 subgraphs on the decentralized network. So that's a cool thing. So we have a decentralized data network that can that everything works for data collection and also data distribution. And as of now, I think that even now that this number went up to 3 million GRT in query fees since the decentralized network launched. So it's kind of going on, kind of at a decentralized data network. So we have a truly decentralized data. Or that's the goal. And the graph consists of this simple entity called the subgraphs. And we can also think about subgraphs in a way like we can put on this lens as read-oriented rollups. So it's a little bit a big term, read-oriented rollups. But like we can think about, okay, so how does data flow through these subgraphs? So a subgraph consists of, a subgraph also always is kind of attached to the blockchain, or at least initially. And then it listens to events on the blockchain, or also it can also have call handlers, block handlers, but basically looks at data on the blockchain. And according to what's going on the blockchain, it decides to store some stuff in a database. And the language that we use to facilitate this is either assembly script or now Rust with substreams. And the mappings that decide which data we want to store into the store can also read from that database. So that simple data flow of like data comes from the blockchain, will go through the mapping, will be stored, and then in the end will be queried by consumers. That's basically the data flow in subgraphs. The cool thing about assembly script and Rust is like both languages are Turing-complete languages, similar to Solidity, which is also Turing-complete, which translates into basically you can do whatever you want with it. So like a Turing-complete language can, for example, like download a file or an image and compress that image and store it into the database. Or a Turing-complete language can generate audio if you want. There is actually some projects that do that, generate audio with a subgraph. Or you can, I don't know, calculate some CK proof over data that was seen, or something like that. So it's a really powerful thing to have a Turing-complete language. And also, the whole thing, actually, I think 2 years ago, kind of come also in this idea, like, so we have a Turing-complete assembly script, so maybe we can build something on top that kind of uses that as then it's by itself is being a blockchain. So this project actually developed into almost kind of a social network that only had very small anchoring on-chain and then built on top. But I explain a little bit more how that worked. Oops, I need to go here. So basically what happened is like that the subgraphs can also download data from IPFS and Arweave. So that they come up with this idea of we can simply have a data edge contract, which is as simple as that, like only a fallback function. And whatever we send to that fallback function, the smart contract by itself does nothing, but the cool thing is the data is stored on-chain. So either we can start to send some data on-chain and have a subgraph then that ingests this and transforms it directly, or we can also send data on-chain that links to data on IPFS or now recently shipped Arweave, so the subgraph downloads this and does something out of it, right? So that's the rough concept. So what happens is like, or according to this example, that the logic moves from the blockchain to the subgraph. And I kind of hinted it already, the graph is, or subgraphs or graph nodes are able to download data from IPFS and Arweave. And this is where this starts to get interesting. So, so primarily the graph subgraph looks still at the blockchain, but it can then see hashes from Arweave or IPFS and then downloads that data. That could be like huge JSON files which can be loaded and then analyzed inside of the subgraph and stored into the store. So that was actually tried out by one of the data scientists at Node. His name is Craig. And so there are, in the graph network, there are multiple gateways which facilitate that clients can query into the graph. Like this is a very common setup that we have gateways to a decentralized network that also applies to the graph. But what's important is that that data that's collected on these gateways, it's very important because it basically says like which subgraph receives how many queries, which indexer served that query, how quick were those indexers able to respond to that query, how much money per query did this indexer get for that query, and so on and so forth. And if you have thousands or hundred thousands or billions of queries, that really gets into very interesting data that just on the gateways. But like, since it's a decentralized network, that data needs to be accessible publicly. Like everybody should have access to that data, although it's traditional Web2 data because it's kind of collected on a server. So they came up with this idea of like, it's a little bit a complex thing, but what basically happens is like the gateways take that data, the traffic data that they have, and upload it to IPFS. Taking that IPFS hash, only just send that IPFS hash back on-chain, and then there is a subgraph that downloads that traffic data from the gateways from IPFS and starts to generate the subgraph that gives us great insights about like which indexer has which quality of service, which subgraphs are queried the most, and so on and so forth. Very cool system. And that same system could be applied by, let's say, an airline company that wants to kind of get rid of the last seats. Why not just uploading lists of seats for flights like onto IPFS, anchor it down on-chain, and then having it distributed by a subgraph or the graph. Another possibility would be think about weather insurance, on-chain weather insurance. Dive a little bit deeper into how this works. But basically, let's think we could have a network of small weather stations, independently operated weather stations that people just run on their or have on their houses that collect data about like how much wind do we have and how much rain or something like that. And since they are independent, we can kind of trust. But now all these weather stations would then upload like every 15 minutes maybe a JSON to IPFS or RViv, anchor it down on-chain, and then we have a subgraph that would then collect and aggregate all that data because they also have like the coordinates of the independent weather stations. And that could unlock very interesting use cases. And the cool thing here is like, when it comes to data publishing and also giving access to the data, we can't rely on the decentralized graph network that's already existing. So when we have these data sets and these subgraphs as described, we can just publish them to the graph network, and then they are automatically indexed by the indexers, and we don't even need to think about access control, rate limits, and so on and so forth, because the graph network by itself already has that baked in, that when someone wants to query the graph network, they need to get an API key or whatever the gateway is offering for access, and then to access that data. And so that's given, because a lot of times that data is not published because it's such a headache to publish data. As I say, like if I would be the CTO of such a Web2 company and have interesting data, and that someone might find interesting, then I think about, okay, what do? I open my server, so that could be an attack vector. Maybe I have too many requests, so I need to work on rate limiting, or maybe I need to want to charge something because the server is not for free, and so on and so forth. With the graph, that's all kind of solved. Just need to upload to IPFS and leverage the graph network. Now it even got easier, like to query the graph. Like there's a new subscription billings online that we can pay with USDC on a monthly basis for a fixed amount of queries. More innovation here is coming, so that's really something. Now, talking about that weather oracle example from before, now when we have a subgraph that had aggregated weather data, it could be actually used for on-chain insurance smart contract, because if there is some trust into that data, we kind of know, did it rain in Berlin or not, right? And then that could then trigger the insurance. Is it paid for that festival that should have happened or not? Because now we have the data in the subgraph, and we can bring it back on-chain. Like there is the chainlink functions that are just, I think, some months ago first launched, but also the Gelato Web3 functions, which are around for a while, that can both ingest data from the graph and then put it back on-chain. So that's very cool. So we can have like off-chain data coming to the graph and then being in the subgraph, being processed there, and then finally put back on chain. So that kind of fills up with this idea of the read-oriented rollups. So when we see rollups, they just have like there will be state coming up from the main chain and will be written down to the L2 and going back to the L1. And with read-oriented rollups, we see like the data comes up, or maybe even from other in, will be quicker to access, but also can be then rolled back on chain with an oracle. So this is the idea here. There is one word to be talked about verifiability. So when someone runs an oracle, how do we know how can we trust the data? So there are different levels of verifiability of data on the graph network as of now and in the future. So as of now, all indexers submit like in a repeating period the so-called proof of indexing. So what they do is basically they say, I saw this and that data, and I signed that with my private key and I put it back on chain like a hash of the data that I saw. So indexers can compare with each other. Did we all see the same data? That's for one. And then when someone sends a query to the graph network, the indexer that responds to that query also sends in an indexer attestation. And then they say, I as indexer, blah, this is the response to that query, but I also say it's true. Now, it could be that the indexers, for whatever reason, sends a malicious or like a wrong result, either malicious or like because they don't know how to run their server properly. But if they do this, and with the index attestation, query attestation, they can be slashed. So this is actually data that can then influence the probability of, or the verifiability of the data that can be put back on chain. So an oracle can take the query attestation and put it also back on chain, that later on, when someone can prove the indexer wrong, they can be slashed. And then now we know indexer stake, and then the more indexer stake, the more they are incentivized to actually give the correct answer, if that makes sense. But that's not bulletproof, right? So there is also like a whole core development team working on the graph, semiotic AI, but also people from EdgeNode that are working on this idea of verifiable indexing and verifiable querying with direct proofs of when receiving the index attestation. Although these are hard problems to solve. I'm not an expert in this mathematics, but that's actively worked on, and we'll get better. So that was it. Thank you so much for your time. You can scan that QR code. That's my Twitter. DMs are open if you have any questions. I can also send you the slides if you want, but I think we also have time for questions.
Absolutely. So who would like to ask some questions first?
Hi, I'm a data architect that focuses on bias. Do you think the verifiability could help basically elaborate or explore like the epistemological origins of data bias and algorithmic bias? Is that something you guys have been looking at?
Data bias?
Yes.
What kind of data bias?
So for example, gender or racial bias. So at the point of indexing, there was a bias inherent due to sort of cultural context or historical context. Is that something you guys have been exploring, that use case?
No, but that could be part of the subgraph actually, because the subgraph is kind of the entry point into the data, into the system. So like whoever writes that subgraph could start to have some algorithms looking for these biases, because also you can write the subgraph with assembly script which is Turing complete, and we could load something into this. Okay. But this is very, like, it's not very very used, that concept now. Let's try to present and hopefully inspire some people to play around with this.
And sorry, second question.
Yes?
I have a lot of clients that their onboarding issue into Web3 is the fact they can't compute and analyze Web2 data or sort of like with Web3. So say like they have smart contracts or NFTs, and then especially hotels, actually I work with a lot. Is on the analytics layer, is there a tool that you've been using that can kind of visualize both Web2 and Web3 data together?
Yes, so the subgraphs in the end are accessible with GraphQL, the data from the graph. So whatever, like if it's Web3 data, which is the graph very well known for, like for most protocols there are subgraphs, look at the ones from Messari. They have very high quality subgraphs that can be used, but also when we follow that flow here to bring in Web2 data into Web3, in the end it will be queryable with GraphQL. There's also currently one research path going on of to explore if the graph network can give SQL access to that data, because in the end it lives in a database. That would, for data scientists, a little bit be more handy. But there's also a tool that helps with Python to access data from the graph network. It's called Playgrounds. So yeah, you can scan my QR code and ask me this question. I'll send you all the links.
Awesome, thank you.
Any other questions?
One of my favorite things is a saying that the event logs are the cheapest storage in Ethereum. With verifiable indexing, is this just as strong as uploading state to Ethereum? Like, if I had a choice between a verifiable index, for example, just create a smart contract and all it does is emit an event. And that event is captured by the graph, and then we have a verifiable index that runs some sort of logic. Like, if in your estimation, is that just as strong as having state on Ethereum?
Yeah, if you think it's true, right? Theoretically, if you think it through, you have an indexer, we have verifiable computing, the data is received, we have a hash of that data, so it's kind of like true. Then you send the query, and the query is also verified, and like end to end, the whole thing is verified. Then theoretically, it has the same security assumption. But that being said, like, for what I know, we are kind of far away from it as of now. But that's the goal, yeah. And that would even kind of lead into this idea that there might be the idea that a smart contract can directly query the graph because it's so verified. But that's kind of dreamy far away future.
We still have a little bit of time if someone has more questions. In that case, thank you once more, Simon.
Thank you so much for having me.